This is just a short illustration of PropCad's capability for generating series-based propeller designs. We'll just quickly generate a gone-based propeller. So the first thing we have to do, select our number of blades. We'll choose 4 blades. We'll enter in a diameter for our propeller, say 32 inches. We'll enter in a target pitch for our propeller design, say 34 inches. We can choose to include rake in the design or not. For now, we'll leave that empty. And we have to select our hub diameter. Wherever you see these little dot, dot, dot buttons, those give you an estimate for some typical values here. So we'll start with, say, 18% hub. Now that we've filled in the main parameters of our table, we're going to use the builder to generate a propeller design. The builder contains all the parametric equations that can be used to build our propeller geometry. We can select the different distributions and equations by dropping down these lists here and selecting from them. And each geometric distribution that makes up our propeller is represented here. For series-based designs, we have a preset column that basically sets up the rest of the builder based on the selection here. So here we can start with a very basic design, the Gone propeller. It's a flat face design with an elliptical blade form. We select that, and we'll notice that all of our distributions here have been set up as a Gone. Now we can change our blade area ratio. Say we want 80% blade area, and enter that here. And we can even go and add some skew into the propeller. So we'll just select, basically there's no skew in the original Gone design, so we'll just use like the typical B series based skew, kind of mix and match one with the other. We hit OK, and PropCad generates all the data needed. All those slices that make up our blade are shown down here. We can plot each of these columns to see distributions of, say, thickness or distributions of skew. And of course, we can see the blade in 3D, which is a huge help to visualize kind of what our design looks like. So that's really the basics for generating a series design. Now we can go and actually, say, calculate the thickness requirements for the blade. And we do that using the ABS rules. So we're going to do that using the ABS rules. The first thing we'll do here, just like we use the builder, we'll go and use the strength and materials button. We'll select the classification that we want to use to base the thickness of the design on. We'll use the ABS rules. These are actually updated now for 2022. We'll select nickel, aluminum, bronze as our material. We'll enter in our horsepower, say 450 horses, and we'll enter in our shaft RPM. So let's say we are at about 650 RPM. We'll enter in a length of the boat, just as determine whether we can use the small rules or the large rules. This boat will be 42 feet long. We'll hit OK. To preview the thickness calculation, we'll generate a report, and this is going to document the required thickness versus the propeller's current requirements. If I scroll down here, we can see the current maximum thickness is 1.1 inches, and we require it to be about 1.418. So what we're going to do is we're going to go and revise the thickness of the root of the propeller to be thicker. And we can see actually it is a bit thin, so let's go in here. So we're going to basically be increasing the thickness of the blade. What we can do here is come in, and here is our root thickness right here in the maximum thickness column. We're going to drop this down from using the default Gone thickness, and now we're going to just update it with our own thickness. And we'll just go a little bit over the recommendation there. We'll go to 1.5. We'll hit OK. Now we can see our thickness has increased here. Now there's no 25% radius, but we can see from the column here that it's about 1.5 there. Good. And now let's look at the thicker blade. It's already been generated for us automatically. At any point, if we wanted to go and revise additional data, we could by just simply right-clicking these columns, setting them to enter, and now they function just like Excel, where we can actually go in and update things like chord lengths, things like pitch distributions, whatever we really want to do here. Of course, we can always go back to using the parametric equations in the builder. We can export our 3D CAD files from here, and we can also generate our 2D drawing. So let's just take a look. I'm going to collapse this table down here and make it a little more space. Here's our 2D drawing options. We can turn these on and off as we need. I'll turn off some of these additional sections here that kind of just crowd the drawing, and we'll hit OK. So there's our 2D drawing generated quickly. Of course, this logo down here can be replaced with your own company logo, and we can turn on and off different views. We can fill in the title block, and of course, we can turn it on and off these different parameters that we might need to. They're listed in the table down here. Of course, it does document our thickness, our required thickness, and the current thickness of the propeller, so that you can see that that complies. And it gives you just a very professional feel. We can also save these reports as PDF, drawing as PDF, DXF, and we can also export these offset reports, which are useful for documenting the design, documenting all the parameters here. So those are all the very basic capabilities. Some additional things you might be looking for. Summary of the characteristics here. We do have the maximum chord length and the blade thickness fraction. We also have a prediction of the weight, which can be important for casting, ensuring that the facility can handle the weight of the casting. If there's anything else you'd like to know, just please contact us. We're happy to give you more information. And we look forward to hearing from you.